Hello students. Now we will consider how a vector transforms. So we have to define a vector by two quantities. One is its magnitude and the other one is its direction. Other than these two properties, we should define a vector in terms of its transformation. How a vector transforms. So if we find out how is the vector transformed, then only we can say that whether it is a vector or not. Okay. Focus on this vector, vector A. This is our origin O. It is starting from here to here. This is the point where we have two components. First of all, consider the axis x z axis. Okay, here we define the vector A is equal to the component L, sorry, not Ax, not x, it is y, yz plane. Vector A is defined as Ay along y direction plus Az along z direction. Okay, now we transform our coordinates into y dash and x dash. That is, we rotate our axis about x-axis. Rotate about x-axis, which will be perpendicular to this direction. Okay. So when we rotate this through an angle, we rotate the angle through an angle phi. So we rotate about the x-axis by an angle phi. Now the components of vector A is now, here you have the component Ay dash, that is the component of vector A along the new axis y dash, and here we will be having the z dash component. Okay, so we have another set of definition of vector A, that is equal to Ay dash along y-axis plus Az dash along z direction. Okay, so these two are the two representations of the same vector in two different coordinate system. Okay, this is in yz coordinates and this is in y dash z dash coordinate. So the vector has not changed, just the components alone has been changed from ay, az to ay dash and az dash. How ay is transformed to ay dash and how az transformed to az dash, this has to be found out. So how a vector transforms, this is what we are going to study in this section. Okay, so what is ay? What is ay? Ay is the cos component. This section, this is ay. Okay. Similarly, at this point, what is this length? This length is nothing but az. Okay. So what is ay? Ay is a cos theta. This is the angle A makes with the y z axis. Okay, it is theta. So it is a cos theta. Similarly, az is a sin theta. I will draw it here. This is our y. This is our z. And here you have the vector A. Vector A. This is the angle theta with the y-axis. So what is this component? This is a cos theta and this component is a sin theta. Okay. Now we have transformed our axis yz into y dash and z dash. So our new system, new coordinates is not like this. I will draw it here. It is like this. This is our new set of axis. It is y dash. This is z dash. And here is our vector A. Vector A. It is making an angle theta dash with this axis. Okay, now the original position was here and the axis has been changed or rotated through an angle phi. Okay, so what are the components? Ay dash, this is Ay dash, this component, and this component on the z axis, this is nothing but a z dash. Okay, now we can try to find out what is Ay dash and az dash. So what is Ay dash? Ay dash is nothing but a cos theta dash. In new coordinate system, this is theta and this is Ay dash. So Ay dash is nothing but a cos theta dash. Similarly, what is Az dash? Az dash is equal to a sin theta dash. Okay, so Ay dash and Az dash, you get it as a cos theta dash and a sin theta. Now what is theta dash? Theta dash is the total angle of A to Y is theta. So what is theta dash? The angle theta dash is equal to theta minus phi. Okay, the whole angle is theta and this is phi and here it is theta dash. So what is theta dash? It is the whole angle theta minus phi. So we write it as cos theta minus phi. Now what is cos A minus B? It is equal to cos A cos B plus sin A sin B. Okay, substitute it like this. So we get A into, what is cos A minus B? Cos theta cos phi plus sin theta sin phi. Now look at this term. What is A cos theta? It is nothing but Ay. Here A, here it is sin theta. What is A sin theta? It is Az. Substitute like this. So you get Ay dash is equal to cos phi Ay plus sin phi Az. Okay. Okay, so you get Ay dash in terms of phi as Ay cos phi plus Az sin phi. Similarly, what is Az dash? What is Az dash? Az dash is nothing but A sin theta, theta dash. Okay, so substitute theta dash by theta minus phi. So A sin theta minus phi is equal to A sin theta cos phi. So what is sin A minus B? It is equal to sin A cos B minus cos A sin B. Okay, so substitute here sin A minus B equal to sin theta cos phi minus cos theta sin phi. So what is A sin theta? It is Az. Similarly, A cos theta is Ay. So substitute like this. You get the value as minus, here it is sin phi, minus is there. So here you substitute as Ay minus sin phi Ay plus cos phi Az. So you get the two terms. The two terms you get the two terms like this. What is Ay dash is equal to cos phi Ay plus sin phi Az. Okay, and similarly Az dash. These are the two components in the rotated coordinate system. Okay, so Az dash is equal to, what is it? Minus sin phi Ay plus cos phi Az. So we try to write down these two equations in the form of a matrix representation. So Ay dash Az dash is equal to the components. These terms are written in the form of a matrix cos phi sin phi minus sin phi cos phi Ay Az. You know the multiplication between the matrix elements. So you get cos phi ay plus sin phi az, that is equal to ay dash, that is written over here. And the second term is minus sin phi ay plus cos phi az, that is equal to az dash. So that is here. Okay, so we can represent these two equations in matrix form like this. So this matrix, this is the matrix notation for transformation. So this is a matrix which represents the transformation from this axis to the different axis, that is yz axis to y dash z dash axis. So this is the transformation matrix. So more generally, if we try to do a rotation about any arbitrary axis in 3 dimension. This is in 2 dimension rotation. If it is in 3 dimension, you can write the similar equation like this, that is ax dash, ay dash, az dash is equal to the components. It's written over here. It has 9 elements. Since it is in 3 dimension, rxx, rxy, rzxz, ryx, ryy, ryz, rzx, rzy, rzz into ax, ay, az. So what will be ax dash is equal to r, the matrix element rxx, ax plus rxy, ay plus rxz, az. Similarly, the transformation of ay dash is equal to ryx, ax plus ryy, ay plus ryz, az. And az dash is equal to rzx, ax plus rzy, ay plus rzz, az. So we can write this equation in a more compact form as ai dash is equal to summation over j equal to 1 to 3 rij aj, where 1 stands for x, 2 for y and 3 for z. So this is how a vector transforms. So if and only if a vector transform like this, we consider it as a vector. So the definition of vector, we should include the transformation of vector like this displacement. So this is one of the important point for a quantity, a physical quantity to be defined as a vector quantity. So this transformation from one coordinate system to another must be followed by a vector. Okay, so this is all about our vector transformation.